I believe floods are our toughest scenario. It's very difficult to predict how bad will be.
The timeliness of information is everything.
Floods are the deadliest, most frequent, and the most expensive natural disasters in the United States and around the world.
We need the right information in the right time in order to make decisions that will make a difference in saving lives or moving resources around.
We're trying to acquire any kind of information that would help us understand the size and scope of the flood.
The faster that we can get the information, the faster we can get it into the hands of the ground teams, the first responders, as well as to the senior decision makers who are allocating limited resources. Data drives effective decisions.
NASA's Earth-observing satellites provide information about the situation on the ground that can only be obtained from the perspective of space.
Texas uses remote sensing from sensor data that's collected to support first responder teams in the field. The satellite data really helps the state in their emergency management for large-scale disasters by showing the extent and the magnitude of a large-scale disaster.
When a flood is beyond a state's ability to respond, the governor asks the president to declare a federal disaster. The Federal Emergency Management Agency evaluates the scale and impact of the event.
Information that they would provide from the state is normally the number of homes that are impacted, number of businesses that are impacted. So we're asked to verify that information within the first hours of an event.
The more quickly FEMA determines the scope of a flood, the more quickly the president can declare a federal disaster and mobilize federal resources. FEMA gathers information from sources including the National Weather Service, the U.S. Geological Survey, the National Geospatial Intelligence Agency, and the Civil Air Patrol. In October 2015, as torrential rainfall soaked the Carolinas, FEMA was contacted by NASA's Disasters Program. The Disasters Program promotes the use of NASA Earth observations in disaster response and mitigation. NASA joined the community of federal agencies responding to floods in the United States. During the major floods that followed, NASA scientists provided data and images from the GPM, SUMI NPP, Aqua, Terra, and EO1 satellites. They used the satellite data to measure and map the rate of rainfall, detect areas with power outages, and predict soil moisture, a factor in flash flooding. The high-resolution ASTER and Advanced Land Imager sensors mapped the extent of flood inundation as the floods evolved. NASA-supported scientists modeled the predicted extent of flooding and mapped the actual extent for FEMA. Because MODIS, ASTER, and similar sensors are optical, they can only collect data in daylight and when clouds don't obscure their view of Earth.
Generally in floods, we have significant cloud coverage that lasts for days.
Synthetic aperture radar, or SAR, can scan the Earth's surface at night and in all weather conditions by transmitting a radar signal to the ground that reflects back to the source. Although NASA doesn't currently have a SAR satellite, other space agencies do.
Those SAR satellites are orbiting around the Earth continuously, but they don't always acquire data when they visit specific place.
Dr. Yoon and his team check whether any of the SAR satellites image the flood area before the flood. To map the flood extent, they need to compare before and after SAR images from the same satellite.
Then we contact them and coordinate with the international space agencies so that they can turn on their SAR satellite and image that area.
By comparing SAR images of an area before, during, and after a flood, Dr. Yoon can use the changes in the Earth's surface to create a flood proxy map.
Blue means the open water due to the flooding, and the red means the flooded area but with vegetation sticking above the water surface.
Dr. Yoon and his group also produced flood proxy maps for the August 2016 flooding in Louisiana.
We estimated that Louisiana would have about 27,000 damaged homes but it was through the acquisition of SAR data and other remotely sensed data that we were able to see that that was a much larger impact than we had forecast.
That information helped FEMA managers decide to increase the amount of resources sent to Louisiana. In 2021, NASA will launch its own SAR satellite in collaboration with the Indian Space Research Organization, ISRO. The mission is called NISAR. The data from the mission will be publicly available.
I think it's going to be extremely useful for flooding, storm surge analysis, earthquake analysis. I see that as a future asset that we'll leverage quite heavily.
NASA's participation in the federal flood response helped form new connections and partnerships within NASA and across agencies.
And it's just a great feeling to see, another agency, another group of extremely smart people come together to help.
The Applied Sciences Disasters Program continues to work with partners in the U.S. and abroad to make full use of NASA's unique resources when natural disasters strike. For more information on the NASA Earth Science Disasters Program, visit disasters.nasa.gov.